before you watch the video on the lambda functions papers, there are some things that we need to know about how to deal with these problems. So you're gonna see a lot of things like this, and hold on, let me get rid of this. And it's gonna seem a bit confusing, but there's a fixed way to look at these problems. So firstly, I want to talk about unused inputs, and this comes up a lot in the papers. So here we have a function called foo, and it returns a lambda function. So this is a function that returns a function. So what's going on is when I call foo x, let's say foo 2, this is going to be equivalent to me saying lambda x3. Okay, so that's the first thing, is that your function declaration and whatever is returning is going to be equal, and in this case it's a lambda function, so you're going to get this lambda function out. The thing that you need to know is, even though I have a lambda function here, notice that this output of the function does not depend on x. That means you can have unused inputs with no problem inside. This is similar to me declaring a function bar x, and I say I return 3. I have the x input, but I'm only going to return 3, and whatever I put into x, it's not going to matter, right? I'm just going to get 3 out. See? Okay. So you can have this you need to get familiar with this concept of unused inputs. The concept that you need to know is the concept that when I declare a lambda function, there are a lot of dummy variables that they're going to come at you with. So for example here, this function takes an input x, which is a dummy variable. This is not the same as saying that, as me declaring x is equal to hello world. This is accessible in the global scope. So when I say I want to print x here, this x is going to refer to this x because we prioritize this local scope. But when I say def bar print x, correct me if I'm wrong, this x refers to this x. Okay, so I'm gonna print bar, or I'm just gonna bar, and it says hello world. This is the x it's referring to. However, when you when you come across lambda functions problems, they're going to use a lot of these variables which look the same but actually aren't. For example, this x is not equal to this x. Okay, let me show you how. Okay, so let's print foo 2 3. Print foo 2 4. Okay, print foo 2 4. What's going to happen is foo 2, I'm running foo 2. This function foo 2, this function foo 2 returns this lambda function. Okay, this x though is not the same as this x. So what's happening when I call this is that I will is that foo2 is equivalent to lambda x3. This is what's this. But this 2 is not going to be used here. This x is meant for this lambda function only. It's like it's being redeclared. Okay? You do not use any x that you've encountered before. This is a completely new x. Okay? So what's going to happen in this function is I have foo2 is equal to lambda x3. Okay, so what we can do is we just replace foo2 with lambda x3, right? These are equivalent. Okay, now we're going to put this 4 into foo2, which is actually this lambda function. Okay, so this 4 is not this x. This 4 is going to go straight into this lambda function. We've already established that these two are equivalent. So this 4 is going to be in here. But we've already also established that this x is not going to be used in this function. It's not dependent on x. Right? So it's going to just output 4. It's going to output 3. Sorry. It's just going to output 3. Okay? Let's run this. Okay? Okay, so now we have 3 outputs here. The first is going to print 2. Because in our function foo2, when we declare our function, we pass in this x. It's going to print x from here. When we declare this, it's going to print 2 here. Then comes the main part. This and this are the 2 inputs from here and here. Okay. So we're going to print. We're going to get lambda x3 here and lambda x3. Yeah. So there's going to be a lot of this part where they have a lot of dummy variables of x, a lot of x which aren't related to each other, and you're going to have to sort out which scope each x is, right? Okay, another example is lambda x. So you have a function lambda x, and then another lambda x. Okay, which has 3. So, and then I have to declare 2 outputs. Okay, like this. Okay, so what is happening? Okay, let's look at this. Let's just look at this thing. I have this big function. These are inputs. They will be evaluated from left to right. Okay, their precedence is from here to here, and so on, from right to left. Okay. Now, this lambda x outputs this. However, this whole thing is one term. We've already seen that if I have a lambda x, it has to output, if it doesn't output something that depends on x, then it's independent of this x. Okay? And the reason it's independent in this case is because I've also established that when you create a new lambda function, it redeclares the scope. Right? So this x is not the same as this x. Okay? This x is the same as this x. It's in this scope. Right? So when you redeclare this lambda function, you're going to get a a new scope for x. And this is evident by the fact that I can change this and get the same output. Alright. So first it was like this, right? I can change it to y because these are not the same. Alright, let's run this. Sorry. Print these two. Okay, let's run this. 7 and 7. These two are equivalent. Okay, we can see that. This 2 is passed into here, but then this is not dependent on this. So all we have is, what's left is, we take this out, take this out. Okay, so we move from here to here. Pause the video if you need to digest. Then we put 4 into y, and this y is equal to this scope y, and we get 7. Let's look at this again. Okay, what happens if I put this? Can you tell me what the output is of these two print statements? What will output to my terminal? Let's go through this. Pause the video and then we'll come back. Okay. We have foo2, 4. Okay, so we know that foo2 gives us, so now it's this, right? We return this, which means that it's basically equivalent. When we call this, we get this. Now we're going to put 4 into this function. Okay, you see? What happened to the 2? Well, same thing as that happened last time. Even though this has x, it is not in this scope. We are creating a new function and everything is being redeclared. So this x and this x are not these two. This is not this. Okay. So now we should get 7 because we put 4 into this and we get 7. Yeah, 7. Alright. Okay, one last thing. Let's come back to this example. Is how do we evaluate lambda functions systematically? What is the what's the way? How do we write it out so that when we do our working it's easy to follow, etc., etc. Okay, we take this and then we look at it, right? Let me copy this. Okay, we have this big thing. Now we're going to put this 2 into the first outermost lambda function. Okay, and when we do that, we're going to replace all instances of this x inside with this input. Okay, now in this case there are no instances of this x in this scope, right? Because we've established that this is not the same as this, and then there's nothing else inside this expression that is related to this scope. So this 2 is going to just disappear, right? We're just going to delete this, delete the 2, and then we're left with this, and the 4 moves in. Okay, and then we can absorb it into this lambda function again. So in the end, we take away everything, but we replace the x with a 4, and we get 7. Okay, so that's how you do that. Now, if we go back to this question, and we change it up a bit, what happens if I put this x? Now, it's different. Okay, let me take this out. Now when I put this 2 into this lambda function scope of x, we do find an x. this does not belong to this. It belongs to this x. So therefore, we replace this x with 2. We absorb it inside. Okay, so we have this. Maybe I should copy another line. Okay, with this, and we absorb it. Okay, we replace this with 2. Can you see how that works? Okay, this whole term is now this term, this expression. And then we put 4 into here. Okay, so what do we get? Put 4 into this x. 3 plus 4 is 7. So this whole thing evaluates to 7. And then we add 2 to it. So we should get 9. Okay? Is that what we get? Is that what we get? No, so we need to write it like this. Okay, just write it like this. So when we want to evaluate this, we look for the y. Okay, the only y in this scope is inside this other lambda function. So first we absorb the 2. Okay, get rid of this extra brackets. Then we absorb the 2 into y. So we take out that lambda declaration and the 2. Then we put 2 inside where we find the y in the correct scope. Okay, we replace it like this. Then now we have this, and we just put 4 inside. Okay, and then we should get 9. Alright, we just put 4 inside. We get 3 plus 4 plus 2. 9. Yeah, so that's all the basics you need to do.